problems. And this presentation is really to give you a feel of how we use markers to really help in the troubleshooting process, the benefits of them, how to implement them, and what you can get out of them. Just to give you a bit of background on what we are and what we do, we're an evidence-based troubleshooting consultancy, and we use this method called RPR, which stands for Rapid Problem Resolution, and this is a very structured method for troubleshooting problems. We're evidence-based because essentially we are obviously going into customers, we are working with their technology teams, or so any managed service providers they may have, looking after various parts of applications. So it's pretty common for us to be challenged heavily on the answers that we come up with when we're troubleshooting problems. So the only way for us to get around that is very much by using an evidence-based approach. One thing we're very keen on doing is really analysing individual problem instances. So what's key to us is really comparing what an individual user has as a problem to the packet data or whatever data we're capturing. So we want to be able to correlate what the user says they're having or the experience they're getting from the application to what is actually happening with the application at that time. So there's various types of problems we look at. It could be an incorrect response from an application or no response at all from the application, or it could be a slow response. It normally takes me 5 seconds to do this. Today it's taking 35. And one of the key things is also around the frequency of the problems. We look at things that we can reproduce at will, and we also look at things that are intermittent. So this could be something that happens to our user base of 1,000 people. We get 2 or 3 problem instances a week, but they're really key problems. They affect them in a negative way, so we've really got to get to the bottom of it. But obviously, having to capture and identify data over that period adds some additional challenges. Hello. Okay, so we're back in the game. Our official motto, our unofficial motto, and this is really sort of the ethos that we work behind, and we have this sign up in our office, is this theory of no phishing. So whatever we do, whenever we look at a problem, it's not a case of us going, well, it could be this, it could be that, we're not really sure. It's very much a case of we need to look at the data, the precise time the user had a problem. We want to wind back our data captures, and we want to see exactly what happened. So the concept of no phishing, it's rather cheesy, but it's this idea that we need to know exactly what's happened, and that fits in with the whole evidence-based approach as well. So what are we trying to achieve with markers? If we think about capturing a problem or troubleshooting a problem, obviously we're going to use some captures in various different guises, network captures being obviously the most common here. We're looking at capturing over a long period because we've got our problems only going to happen 2 or 3 times. So we're going to have a whole bunch of data in the gigabytes, hundreds of gigabytes, terabytes range. And we need to be able to identify a particular stream or particular user transaction inside that collection of data. So really, at a high level, here we've got a stream. We've got an HTTP GET followed by some service time from the server, a response. And we need to be able to identify this in our big group of packets. So the way we do that is essentially we want to add a marker inline to our data stream, or inline to our data captures, that directly after the user's had a problem. If it's a reproducible problem, then we want to add a marker before it as well. Send a marker, recreate the problem, send a marker again. And this just gives us a really good way of bookmarking our problem time frame in our data captures. So markers help us troubleshooting in various ways. As I just mentioned, it gives you the ability to identify the problem time frame of this particular problem instance. It also allows us to insert diagnostic information in line with our captured data. We've all had the problem where a user reports a problem, it gets forwarded on through a service desk, through some escalations, and lands on your desk. This user had this problem at 9:45, can you have a look at it? That's such a wide window, you've got no idea what you're looking at. So this gives you that ability to add information in line, as I say. Another advantage of this is the fact that we can use markers of data that we recognize to synchronize our timestamps across different data captures. It's quite typical for us to capture data end to end. If you think of a normal application, you've got a user sat in an office, you've got a data center providing some services and a whole load of other things. So you want to probably, it's quite common for you to be capturing in both of those places. So we want to be able to see our markers in both places to be able to synchronize timestamps, but also to help us find the packets we need in each place. On top of that, as an added benefit, we want to be able to add our markers into external data sources, things like weblogs, OS traces, stuff like that. And the fourth and final really sort of thing that markers helps us with, and this is quite an important one, it gives the ability for the users to send markers and mark the data for us without us being there. Now, normally we like to sit with our users when they're having a problem and wait for it to happen. But as we know, we're talking something about intermittent problems. It's not practical for us to sit by a user all week. Who knows where they're going to be? They could be out and about. They could be in meetings when they have a problem. It's just not going to work. So we need the users to be able to mark the data and give us a helping hand when it comes to that analysis point of view. So as a kind of high-level approach, this isn't meant to go into our process at all, and I don't want to bore you with processes by any means, but if we think about how we troubleshoot a problem, there's going to be various phases to this. The first phase being our planning and capture, getting a good understanding of what the problem is, what actually do we mean by the problem, agreeing with our customer, okay, the system's performing badly, what do you mean by that? Well, it takes 20 seconds, good is 3 seconds. Concrete numbers around what we call good and bad. And through this phase as well, we're talking about deploying our captures. We tend to use our own commodity-based servers that will configure dump cap running in a ring buffer, capturing data over a long period of time. However, depending on the customer's requirements and their own packet capture technologies, or infrastructure rather, they may have things like NetSharks, InfiniStreams, NDACINRs, whatever, capturing data in a long period. So if we can get the PCAP data out of that for us to process later, then that's what we'll do as well. But essentially, we want to make sure that we've got capture data for us to look at. Then the second phase is that, as I say, capturing the specific instances of the problem. I click the button, it took too long, or it took over 20 seconds, this is a problem. And then the third phase, which is obviously what we're all kind of interested in here, is analyzing that captured data. Now, the markers help us in all three of these phases. In the first phase, it's involved with, we're going to design our markers. We're going to figure out the best way to deploy our markers to our users for use later on. Obviously, during capture, that's when the user is going to send the markers. And then this third phase of analyzing the captured data, this is when we're really going to see the benefit of using the markers. So if I think about the marker solution, we've got a pretty basic application here. This is a thick client app, if you like, running on a single user desktop, going across a wide area network and talking to a server. We've got a capture point near our PC, and we've got a capture point near our server. Obviously, we've got the application data traveling between the two parts, and we want to be able to see our marker going along that same path. One of the interesting things about the fact here is we've got the marker going in one direction. We don't really care about it coming back. We're not necessarily interested in the response from a marker, because what we want to do is we want the marker, and then we want to back up from there to actually find the traffic and the packets that we're interested in. There is an exception to that, which I'll come on to a bit later on. So If I think about the simplest marker that we can use is a ping utility. We can send a single ICMP echo request of a set size that we know into our packet traces for us to then find later. So the two commands there, obviously, for Windows and Unix type stuff. So the point is here is that we're using the -n parameter to send one ping marker, and we're also setting a length of 100 bytes. As you know, you're going to have a load of ICMP flying around your network for various things, monitoring solutions, systems checking whether things up or whatever. So we need to be able to make our ICMP packets stand out from anybody else's. So I'll just dive in and give a quick sort of demonstration of what we mean and how this works. So if I come out of this. So I'm setting myself up for failure here, but I'm going to try and do some captures at the same time, and hopefully it will work. So I'm just going to use a start Wireshark and capture on my VPN adapter here, because the server I'm interested in is back in our data center. So if I think about browsing the application, I've got a very simple application here. It's a single page application. It's got a start time and end time and a duration of this request. I'm going to keep pressing this refresh button until I get a slow delay. It should happen once every 4 or 5 times, depending on how it's been coded. And here you can see normally we get a response of less than a second, and we've got a response here of 5 seconds. So that's clearly an issue. Okay, so at this point, we want to mark our data. So if I dive in here, and I'm going to just send that simple ping marker with 1 and a size of length of 100 bytes, and that'll go away, and obviously that's now in our trace. So if I look in our trace, obviously I've got a whole bunch of data in there, and I can just filter based on ICMP, and I've got our ping request and ping reply in there. So as we were talking about here, a single user PC, and I'm capturing on the PC, then we know that we're in that capture point close to the PC, and our IP address, the source IP address, is really going to be the IP of all our interesting traffic. So the delay, or rather the traffic to our application server or web server in this respect, is obviously going to be coming from that IP as well. So if we use the ability in here to zoom in on all the traffic between my PC and the web server, using a conversation filter and looking at obviously just the IP streams, then I'll do that again. Then we can see we've still got our marker highlighted, and we can see above that what happened immediately beforehand was this HTTP traffic to our web server. And we can easily step back there and go, okay, this was the thing that happened exactly before the marker was sent. So then we can move back, and there we can see our post, and I'll get a 5-second delay there. You know, part of it's not that important here, but it's the fact that we've gone straight to the packets that are relevant here for this particular user. So obviously, asking our user to send those ping markers using a script like that's not ideal. So we can have the ability, obviously, to use some kind of marker script. If I just minimize that, we can deploy a batch script on our users' desktops with some instructions and say, you know, each time you have the problem, we want you to go in and send a marker. You know, normally we would typically deploy this using some kind of group policy or other bit of access to a user's desktop, so they have it to the users that we know that are friendly users who are going to help troubleshoot our problems. So, and obviously, in each time they get a problem, we're just going to ask them to press a key, and it's going to send us another marker. And our marker length are incrementing here, so we can identify it, and the users can tell us, okay, I sent marker 104 just after I had this problem. And again, we then going to have all that data in our capture, and again, use it to be able to filter and zoom in to exactly the packets that have the problem. So I go back to my presentation in here. So there are some obvious limitations of ping markers. Firstly, you're going to have your firewalls or devices in the way that are probably going to drop your packets. So you may see your ping markers close to the PC, but you may not get them in your data center traces for correlation. And that's a bit of an issue. They're not going to cross any proxies or load balancers that you're going to have sitting in front of your application, which is obviously fairly typical. There may be policy restrictions in place that you've got to block your users doing this kind of thing. They may have the command prompt block, for example, may not be able to launch batch files. And they really contain pretty limited user information about this particular problem. Yes, we've got the user's IP and the time frame, but wouldn't it be better if we could get some more information? So the solution to that is to use HTTP markers. If we've got our system that is pretty similar as it was before. We've now got a browser and a web server. I know our example used it, but we've now got it in the picture as well. And in between that, load balancer and another capture point. And obviously between end to end, we've got our HTTP traffic coming from our client across our WAN to our load balancer and then onto the web server. And what we want to be able to do is we want to be able to send our marker across that same path and ideally hit our web server. So how do we do that? We do that by sending an HTTP GET request to a specific URL that we know about and that will stand out from the rest of our application traffic. If we think about the components of an HTTP transaction, and this is I'm more than certain you all know the basis of this, but if we think about identifying our markers on the network, we just need to know a little bit about how HTTP works. It's this concept of a request and a response. An HTTP transaction, very simply on the wire, can be broken down to, we have the first few packets is that TCP establishment, session establishment, SYN, ACK, followed by our HTTP request. In this case, we've got a single GET packet followed by a standalone acknowledgement from the server. We call that the request. And then the response from the server, how many packets finished, and then acknowledged by the client as well, followed by whatever TCP teardown is going to be in place. In this case, we've got some fins, but quite typically you'll see resets as well coming from various different load balancers. As I talked about, we're kind of all about enhancing our data captures with data from other external data sources as well. Weblogs are one of the key things that we look at, and it helps us when we talk about things like encryption later on as well. But I just wanted to just quickly touch on it at the moment that one of the key things to notice is with a packet trace like this with our request response is that where our weblog is going to log our access requests, when they actually get logged to the log and what the timestamps mean. So here, for example, for this, we've got the weblog is actually getting created when the response is getting sent to the client. Specifically here, it's when the last acknowledgement from the response is getting sent to the client. However, the timestamp of our request or of our weblog is actually the start of the request. So this is why in your weblogs you'll see, obviously, a load of things out of order because you've got stuff getting logged down here, which actually the timestamps are back up there. And that's the reason for it, and it's useful to know that from when you're trying to correlate those two data sources together. So if we look at a simple, it's come out of there. A simple example of an HTTP marker, then I can go back to my application, hit refresh a couple more times until I get a delay. As you can see here, I've got a delay of probably 5 seconds on this one. And then I can just write, I'm going to put my name in there, and I'm going to get an HTTP 404 not found back because obviously that page doesn't exist. But again, this doesn't matter to us because we don't really care about the response. Actually, in certain cases, it does help because we know we're getting a 404, which is a pretty useful thing to know. So then if we look back into our trace and have a display filter in here, we can search for our, and what am I doing? http.request.uri contains Matthew, if you can see that. then we can see our marker that has been sent using that get, and obviously, and then as we did before, we can then filter on our conversations for that particular IP, work back and see our delays again for that particular user. Which is great. So at this point, I'm just going to introduce a little tool we've built to make this life a bit easier for people. And for some reason, it's gone back to the beginning, so I'll have to whiz forward. Okay, so we have this tool called TribeLab Sonar. You might have seen the TribeLab stuff around here, in the Reef and at the vendor exhibition last night. One of the free tools that we offer as part of the TribeLab project is TribeLab Sonar, and this is really a free tool for creating and sending markers. That process I just showed a minute ago of creating the HTTP marker it works perfectly well, but it's a bit fiddly and it's perhaps not so user-friendly as it could be. So the TribeLab Sonar is a tool that is just used using browser standards such as HTML, JavaScript. It creates user-friendly links that we can distribute around our user base. It's a single page available for download, so if you can't get to the TribeLab website, or your user specifically can't get to the TribeLab website, then you can just save the Sonar tool, stick it on somewhere that you have access to or your users has access to, and they can go away and use the tool from there. So if I give you a quick example of that as well, it's just going to make life easier as we go through seeing how to send things. So as I say, if I just open up a browser and go to tribelab.com/sonar, it'll take me to the Sonar tool. So there are a few options in here to think about. The first thing is our URL that we're going to send our marker to. This actually supports multiple URLs. So for example, if your traffic is going 2 different routes to your data centers, or you've got 2 different data centers and you actually want to send markers to multiple capture units in different data centers, then we can just add different URLs in here separated by commas. But for the purposes of this, I'm just going to send it to my one server. Oh, sorry. I'll have to make sure it doesn't restart everything as well for me there. Okay. There you go. You can see it now. Okay. Back to where I was. tribelab.com/sonar, and there we've got our URLs. So I'm going to give it. So I've given it in there the URL of my server that hosts that little application for us. I've left the default HTTP port of 80 in there. The next box down gives us our username. This is obviously something unique to me. In my case, I'm going to use my name, but obviously you go on from there. The seed is a value. Each time we send a marker, we're going to increase the seed value so we can identify different markers in our application, or in our trace rather, and a timeout value as well based on how long you want the tool to wait. 500 milliseconds is probably going to meet all the needs. So we've then got the user link, which I'll come to in a minute, and then this send marker button. Sending a marker is as simple as obviously just clicking the send marker button. Below it, we get a log entry added that gives us the details of when that marker was sent. And then if I look at my trace, I can obviously find it based on, I'm going to do just doing a frame contains. And there's our marker. You'll notice that as well as the marker number of 1, the seed of 1, we've also got an additional parameter called TL marker with a universally unique identifier, and we'll come to the purposes of that later. But really, we don't need to worry too much about that at the moment. So obviously, each time I keep pressing my send marker button, we'll start getting a new entry, and a new marker will be sent into our trace. So this comes on to our user link. And this is the user that we can distribute to this is the link that we can distribute to our users via email. And what this does is this hides basically everything on the form other than the username box and the send marker button. Our customers love it. They call it the big blue button that makes all the magic happen. even though, as we've just seen, it really doesn't do anything at all. But it's a great way of sending things to users for them to understand what we're trying to achieve. We're trying to identify a specific problem instance, and we need them to help us diagnose that, and they need them to help us to mark our data. So the user would just come in here and enter their username. They'll get prompted if they don't. I'm just going to give it a my user. And we're going to ask them to press the button each time they have a problem. And obviously, as you'd expect, these markers are going to pop into our traces as we go. OK. Now I'm going to try and flip back to this without it going back to the beginning again. There you go. So obviously, that's a very simple single user desktop with some HTTP traffic. We could jump into that user's traffic just by filtering in their IP. But more typically, in a large organization or any really organization, you're going to have multiple users coming from the same IP address. And so we need to overcome that challenge. So here we've changed the diagram to actually our desktop on the left-hand side is now a terminal server. We're going to say we've got 80 users on this terminal server. It could equally be some kind of NATing device, firewall, proxy, etc., things like that, that your users are all hidden behind. But the point is that your capture point 1 on the left here, you've got your user and 79 other users' traffic all coming from the same IP, and we need to be able to find their traffic. We can't just find our marker, then back up and look at the previous HTTP traffic, because obviously, how do we know it's our users? So in that respect, we then need to start thinking about other ways of getting around that. Again, we've got our HTTP traffic coming from left to right, and so we need to find something unique in our HTTP traffic that we can link to our user. Here I'm going to talk about using a session ID for our application, but it could be something like an NTLM username or something else that we can find in our packet traces. And underneath that as well, we want to be able to find that same data in our markers. Now, one of the great things about HTTP markers, but also a thing to be careful of, is the context of browser context. With modern-day browsers, what we want to be able to do is we want to be able to send our markers from a second tab in the same browser. And what that means is that the information that gets sent, so in this example, the cookie session value gets sent, is going to be sent the same value in our second browser as our application browser. And that's really good, because it means we can obviously tie the traffic together. So if I think about our application here and how we can do that looking at our trace, if I look at my this marker here and I just filter out this TCP stream using the conversation filter TCP, then obviously we've got a marker in there sent. So then if we look at drilling down using the HTTP dissector, then we can see, where is it? Perhaps not that one. Let's find the other one. Okay. This is why you never do a live capture, right? Okay. Let me add another request in here. Okay. And then I'm going to send a marker to, I know why. It's because I haven't actually sent, my marker, I didn't set it up correctly. I didn't use the full path of my application, which is actually ASLDev/UI. Now I've got ASLDev/UI. Things might work as I'd like to work. So then if I look in here, then we can see that we've got my cookie value in here with my JSession ID. In this case, it's a Java application. So we've got a JSession ID. It could be an ASP.NET view state or PHP, whatever. There's going to be something unique in your HTTP traffic that's going to track your user session, whether it be authentication, as I mentioned earlier. So from this point, then we can create a filter based on that, which will give us the HTTP cookie pair up the top. And then we can filter on that, and then we can see, okay, look, we've got our marker, and we've got all these requests beforehand. If you can imagine here, you've got 20,000 HTTP requests in this same period, and they're all for your other users, we know that these 11 or 10, if you exclude the marker, HTTP requests are relevant for my particular user. So it means you can then drill into those sessions one by one and find out what the delay is there. And if you can think, you can match that up through the applications. So that's how we do it with HTTP markers. I'm not going to bother going to the thing there. So the next thing is, well, what happens if you aren't analyzing web traffic? I know a load of our stuff is web traffic, but it's not always going to be. Now, if we look at our marker here, and go into the stream again, what we'll see is that of our get, there's some retransmissions there because it's going to our data center in Milton Keynes in the UK. And specifically, if we look at the packet bytes on the right-hand side for our TCP payload, right at the start of the data is our GET request, followed by our URL. So all we've had, all that's happened is a TCP session establishment, followed by, that's the first bit of clear text you're getting through for these packets. And this is really good for us, because this means that what we can do is hello? There we go. So we can actually use HTTP markers for services other than web servers. So if I take the example of an SMB file server, what I'll do is I'll just open up a page on our file server. Again, this is going to take probably a couple of seconds in there to quickly come back with a window. There we go. So that's just opening a page on my file server in there. Then from there, we can do a filter on SMB and find that traffic, or SMB2, because it's a Windows 2008 or something server. Then we can see all our traffic. This is our normal user traffic they'll be having. And then every now and again, they've got a problem. They get disconnected from a file system or something like that. OK, what are we going to do? Well, we can use our marker tool in here to update the URL to send it to HTTP, and then give it the name of our file server, change the port number to be the port number of our file server, and then we can send the marker like that. Now, going back to Wireshark, obviously we can't find, the dissector isn't going to dissect HTTP traffic sent to port 445, so we need to find it somewhat in another way. And if we do that by doing our frame contains in there and having a look at our filters, what we can see is we've got this bottom entry here, which has been decoded by Wireshark as an MBSS continuation message for our SMB traffic, even though we know it's not. It's our marker. And obviously, if we look in our packet bytes, we can see that this is, in fact, our marker. So what we can do is, it's any service that listens to a TCP port, we can send a marker to. If we actually drill into that server, into that stream, rather, you can see what happens to our marker is actually we get the session establishment, that MBSS contains our marker, and the file server goes, hang on, that's not file server traffic, I'm going to reset the connection. But again, as we mentioned earlier, it doesn't matter because we're not interested in the response. We're just interested in getting that MBSS connection message in there, continuation message rather in there. So this is really good because it means we can, as I say, send markers to anything we want. There are other things we can do with this as well. So if you think about it, if you think your application perhaps has a search functionality, for example, you search for a customer's name using various different parameters. If you know the URL of that or the formation of how you can do that, then we can send a GET request with your marker information that's going to go through our traces, hit our web server, and also, if we're lucky, going to be sent to a database server for a query, for example. So it means that we can identify it there just doing a rogue test search. So this is that, I go back to that point of thinking about how we can carefully craft these markers during the planning stage to then aid us when we're talking about analyzing later on. So there we go. I've done it again. I can jump through. So that kind of brings us on to, that was all very nice and happy days. We were talking about HTTP traffic, but obviously more commonly these days we're going to have encryption from our clients to our servers, whether that be terminated on a load balancer or directly through to a server or various things like that. So this adds another couple of challenges for us to overcome. The first challenge is, how can we identify the markers when we can't see the payload? And secondly, how can we identify our users' encrypted streams in a multi-user NATed environment? And I'm going to talk about these things separately. So, updating my HTTP transaction components now to think about HTTPS transaction components. We've got this, we've got our TCP establishment, again in the same way, SYN, SYN, ACK. We've then got an SSL handshake. In this case, we're using an abbreviated session handshake. There's no key exchange. I'll talk about that a bit more in a minute. And then we've got an HTTP request that we can see because we've got our source port. We can see which direction it's going in. And we've got our HTTP response later coming back, followed by that same teardown. And understanding that and seeing how we can see that on the wire is going to help us identify these encrypted markers. So if I go back to my marker tool, what I'm going to have to do is I'm going to have to start another session of Wireshark capturing here because I need an SSL server or a secure server. So I'm just going to capture on my Wi-Fi interface, and I'm going to use a BPF to identify just to my the web server I'm interested in. So if I open up our web server in here, this is the community TribeLab server is actually an HTTPS server. What makes life easy for us in this situation, and it's quite a common deployment technique, but it may not be the case everywhere, is the fact that we're upgrading HTTP sessions to HTTPS. So I try and go to the insecure version of the TribeLab website, community.tribelab.com, and it's redirected me to the HTTPS website. Using an HTTP code of 301 that we can see in our traces, but it means that we can see our request in the clear and our request encrypted as well. So if I think about sending a marker to this server as well, so I go back to our Sonar tool and I update my URL to be tribelab.com. I'm going to send it to our unencrypted port 80. And I'm hoping it's going to get redirected. So if you can, hopefully you can see the URL there that we're sending it to. So if I send another marker, okay, it's gone. We've got a new entry logged in. We need to find that marker in the trace. So if as I did before, I can do a frame contains in here and find our marker. Okay, there it is. And if I just look at this particular TCP session, we've sent the GET to this URL, and we've been sent back a 301 redirect move permanently. And if we drill down into what it will say is actually you can't get to here by HTTP, you've got to go to HTTPS. And what the browser will do, and specifically what the marker tool, the Sonar marker tool is going to do, it should follow that 301. So if I just filter, if I remove the filter for this stream and filter for this particular IP pair, there's our redirect. And hopefully afterwards you can see we've got a load of encrypted traffic happening here. Load of SYNs getting sent to 443. Now this is Google Chrome being eager to open a load of ports because it thinks I'm going to download a load of stuff from it, even though I'm actually only going to download, I'm only in this case sending a GET that we know isn't going to get found, and we're going to get a 404 response. So if I drill down and look at my traffic there, I can see the handshake happening for everything. And then moving down, I can actually see some application data. But what I want to do is, I'm going to update my filter because I really want to find my encrypted marker. And I'm going to put some brackets around my stream there. And I'm going to look for, I'm going to get rid of my SSL handshake. So give it a not SSL handshake. And I want everything longer than TCP length of 0. So I want to get rid of all my sins and my synax. So in there I can now see my unencrypted markers and the encrypted version on the way back as well. So if I leave that filter in place and send some more markers, what you'll see is that after the first one, you'll start getting a consistent pattern. You're getting a 404 back to the request, and we know here in frame 399, we've got our request, encrypted request, and here we've got the response coming back in packet 411. So if I send another one there, obviously we can see this pattern repeating. What this means is the fact that we can then identify what a 404 is for our marker and what our marker will get back from the web server. So if I look, we know that consistently with a 404, you're going to get the same response bytes, you're going to get the same size of response from the web server. So we can do a filter based on that and have a look at our segment length of being, what did I say, 516. So if I update my filter to be, okay, give me traffic coming from my server, so source port equals 443, so I'd only want encrypted traffic, and I only want it having a length of 516, and I've put a typo there and put another equals in, then we can see our markers coming back from the server. And again, obviously, we'd expect we're going to see more of these come through. Now, this is really, for us, this is really cool because it really means that you can identify where your markers are even though you can't actually see the encrypted data. Obviously, you could go down the lines of encryption, of decrypting it using private keys and stuff like that, but we never get to that place because people don't want to give us their private keys, rather unsurprisingly. So that was our first challenge. How can we see our markers when they're encrypted? And then which moves us on to our second challenge. How can we see, once we've got our marker, how can I then find my traffic for my particular user out of the other 80 users that are coming from the same IP address? And for this, if I just jump back into my PowerPoint, I hope I've pressed the right key this time. Jump through that, we talked about that. Then you need to have a quick understanding of the SSL handshake. This isn't supposed to be a big, this is how SSL works or anything like that. It's just really to provide enough information for understanding what we're trying to achieve here. So really with SSL, there's two types of handshakes. There's going to be a full handshake, which we'll talk through first. The first packet's going to come from a client, and it's going to have a session ID value of 0, which is this red value in the middle here. And the server's going to respond, giving it a server hello, and it's going to allocate a session ID. In this case, we've got AB27 ... It's a 32-byte integer that it's going to do, and it's going to go through a whole process of setting up a new SSL session, doing a key exchange. Depending on ciphers, you're going to see a few more transactions left or right from the client to the server and back again. Eventually, the session will get set up, and you'll see some application data from the client. And this is obviously, in the case of our markers, this is going to be your application data here. It's going to be your first request. So where I talked about earlier, the idea of the context of a browser using our markers in a different tab of the same process or the same overriding process with an internet browser, is that it means that when we send our markers, what they're going to do is they're going to send a client hello using our SSL session ID from our core traffic. And that's really cool, because that means that we can, if we're lucky, we can identify and tie those two things back together. So what happens is our marker gets sent, along with our application traffic gets sent with a client hello using this session ID. The server will have a look, see if that session ID is still in its cache. Each server is obviously going to have an SSL cache that it'll store for a certain period of time for that particular client. And if it's happy, then it will keep that session open, and it will skip the whole key exchange. Don't want to bother with that anymore. Too easy for people to intercept and crack. So we're just going to send the session ID back, and we're going to jump to the bottom of the handshake, followed by a finish, and followed by our application data. And this concept of an abbreviated SSL handshake is a way that we can tie together our users' transactions based on our marker, which we know how to find in the encrypted data because we've learned the length of it, and the rest of their traffic. So if I jump back to my packet capture and I have a look and I find one of these markers here, we've got these four markers, then I can, if I filter just to that particular conversation, and then I move back up again, we can see that we have our client hello. Oh, excuse me, I should have filtered on the TCP stream. Oh, I'm still not on the right stream. Thank you. Yeah, I'm working on it. And I've got there. OK. So that was easier then because you didn't see me do it wrong. There you go. We're up now. OK, so we know from our going, if I'll just jump back to the previous filter that had the 4 markers in it that we'd found based on their size, and I just have a look at this particular stream, then we can go back and we can see that our client ID, our SSL session ID, using the decode in here, is reusing the session ID starting with whatever that long number is there, 8548. So from that point, what we can do is, sorry.
Does any of that go through, like if you have another concentrator or a proxy? That doesn't go through all of those, does it?
It's not going to go through those, no. It's going to go to the That's right. So it's going to get as far as wherever your SSL is terminated. So your load balancer or whatever. So from that point, we can prepare a filter based on our session ID. And then we can see all these other client hellos and all other traffic. We can see they're all sitting on other packets, on other sessions. And we can obviously then, in the same way we did with our unencrypted traffic, we can really look at that user's traffic. So from our perspective, that's, if you're doing this kind of stuff, this is a really powerful way of being able to identify that idea of correlating the user's specific transactions with a marker. So,
you take into account that the session IDs are refreshed every 5 minutes in more browsers?
So if they're going to get refreshed, what you'll see is that the server will respond with a new session token, and you can follow the chain back that way. So if you've got a different, so if you try and send, well, in fact, it's here in front of me. If you try and send this client with an AB27 and it's recycled for the server, then obviously you'll get the server hello, and you'll get a new session ID allocated there. So you need to step back through the chains. But yeah, but it is possible that way. And one other thing that I didn't talk about, and I'm going to remember to press the escape key before I filter back, is the other advantage that, and as I talked about earlier, we're really keen to integrate other data sources to our packet captures, and this idea of the weblog. Here we've got an Apache weblog it's for a different time period, but because I haven't just copied it off there. But what we've done is we've enabled our JSession IDs to be logged in our web trace, and we've also did I say JSession ID? We've logged our JSession ID in here, and also the SSL session ID, so we can compare. So where I've got my marker here on the bottom right, if you can see that, we can then and trawl our web logs and find all the other transactions, all the other transactions for that particular user. And that makes it really easy.
You can use that for response time management, just using your marker
Yeah.
in the logs of the server.
Yeah, yeah, absolutely. And the one other thing that we logged in here as well, and we like to encourage people to do, is, if I can draw a line under it here, is this value here, which is 62285, and this is the client port as well. So this is the TCP port. And this isn't these three things aren't default in most web logging, but they're from a network analyst perspective, if you're trying to tie encrypted traffic to unencrypted traffic, it's really helpful. So I just want to give a quick summary of really the benefits of HTTP markers that we've talked about, and I've remembered to press it back on there, so I'm doing well. Okay, so this idea of our markers are going to follow the path of application traffic. They're going to get across firewalls. It may be that you've got a load balancer or a firewall that's doing some URL inspection, and it won't like the fact that I've sent my markers there to Matthew and it'll get blocked. Well, you can craft them in a different way that you're actually going to send them as URL parameters, key value pairs, for example, on the get and cross it that way. We've seen that it's useful that they can be crafted to give additional diagnostic information. There's no installation or special permissions needed for doing this. This is part of your core browsing, your core browser facilities, which makes life a lot easier. And we can deploy that link to our users by email en masse and say, look, feedback, we want your information. And again, we talk about how we can correlate that in the log. So just as a quick summary of going back on our objectives at the beginning, we can use this to identify the problem, the data for a particular problem instance by bookending our data. We can synchronize times between our different data sources. And we can identify the problem time frame really well without having to rely on stopwatches or anything else. But it's not limited to the data sources mentioned here. Like I say, you can pick up markers in OS traces, such as Procmon, Sysdig, ETL, and things like that, because you can pick up, knowing your TCP port connections, your markers going on, you can find those in these other tools as well. And again, which gives you another ability if you're going to drill into what we would call functional unit, such as an application server or an operating system, then you immediately know where you are, and you can go from there, or SQL logs. So I just wanted to give a quick overview of the abilities we have in the TribeLab Workbench tool that we've been talking about in the Reef and in the last night at the vendor sessions. And Workbench does a whole bunch of stuff, but it does some stuff specifically around markers that I just want to show you with a couple of clicks. It allows us to find markers over a group of files. Obviously there I was opening up files. I had the file open, it was a small file. I could see my markers as they were getting generated. But as we talked about, we know we're going to be dealing with large quantities of trace files, so we need an easy way of finding our markers. So what I'm going to show you is based on, it is all possible in the community edition of TribeLab Workbench. And it's really just very much a couple of clicks operations here. So if I open the application, I'm going to load a couple of trace files that I was using for examples earlier on. I'm going to load into these just two PCAP files. I'm going to click on our markers button at the top here, and I'm going to click Find Markers. If you remember earlier when we were looking at the HTTP markers, it added a UUID in it, and essentially this tool picks up that UUID. There it's gone and searched away those files and found all the markers that I generated earlier. It's also picked up our ICM ping markers based on the length of the data. Here we've got them with 100 bytes, 101 bytes, and things like that. And we've got a log of all these different markers in there. So this is useful for finding markers, and I'd encourage you to use it there. From there, we can right-click and go show the frame in Wireshark, and we'll pop it up, and we're back to where we were. We've gone directly to the frame, and we can immediately start analyzing our users' traffic from there. So that's a very brief look at what Workbench does in relation to markers. So if I think that's pretty much all I've got to say on this subject. So if you've got any questions, then I'll happily answer them. Yes?
The online marker that you on your own website, you increase a marker value.
Yeah.
You do that on provide a link to an internal server to the customers. Is there also there's no increasing marker?
Sorry, could you?
The marker on your website has some JavaScript or anything that creates another value for the marker.
Yep. Yes.
If you send it, you can send a link to the customer by email. That's just a website address.
Yep.
Prefabricated, but there's no marker increasing there, is it? Is there?
Yes, it will increase. It will increase as well from the back of when you press the button. It will increase for the users as well. Yeah. So if you look, yeah, absolutely. So if you view the source, it's got it all in there the way that it's doing that. Yeah. And because you got the unique value for the user, the unique value for the markers. Yeah. You can set it up. Anybody else?
You're running into trouble sending markers to non-HTTPS ports with the grading stuff. Because you're sending non-formal data to your
Well, yeah, but I think like in the example there we were talking about the SMB traffic, the server just rejects it. I mean, if you could break the server like that, it'd be quite easy. But yeah. Cool. Well, thank you everybody for your time. I hope you found that useful. Cheers. Thank you.